What if I ask you to pick one topic that's trending nowadays in the technology environment? Well, you would probably choose artificial intelligence. And what about if I asked you to pick a topic that has, well, forever fascinated from childhood to, well, your adult age? Well, you would probably choose space. And what if we combined those two topics, artificial intelligence and space? Well, that's something we're going to talk inside this video. Space companies are valued billions and billions nowadays. Private ones are growing up like those common startups and scale-ups we've been used to see in the tech world, like 20 years ago in the tech bubble of 2000s, maybe, well, like cryptos maybe, or those highly technological companies that are valued billions, sometimes trillions on the market. Well, that's something which usually occurring on the United States stock market, and today we are talking about an American company again. That's a phenomenon that's still confined within the borders of the United States, but has a global impact. Now I'm talking about Elon Musk and xAI, his company, which was recently acquired as a public announcement by $1.25 trillion by, well, again, another company of Elon Musk. Well, some would say that's just a marketing maneuver. The announcement, all those claims around the announcement are just a political marketing maneuver just to have more attention by the media. Well, that's for sure a factor, and that's probably the truth, but not the only factor within the whole thing. Well, let's look at the technology behind this, how this would impact the whole space ecosystem. Well, first of all, that's an artificial intelligence company, but that's not the software which is the point here. Well, it's for sure an important part of the whole thing, but today we are going to talk a little more about the hardware and why more and more companies are targeting space as an ecosystem, as an environment to place, well, I think starting to think to place their data centers. Before starting, I would like to thank you for commenting below our latest video, and especially those who reached out at info@spaceinfo.club, our main reach out email if you want to contact us, or through our direct messages on the Instagram page. So thanks for being part of this and choosing the next topics you would like us to talk about. So another thing, if you want to this project still grow up, well, subscribe to our channel because it's completely free for you, but it's of a huge help for us all. So let's talk about the reason why companies are targeting a space environment to place their data center. Well, for what we know, maybe there's some military government, some military aspects and satellites that we cannot know that are already flying in space, transporting the data center for, well, US, China, some other government or military forces. Well, we just cannot know. But more and more public-private companies are thinking about building satellites with data centers on board. The reason why is that this kind of hardware is more and more required by high energy consuming applications like artificial intelligence, or without claiming this word useless in this case, well, just think about those heavy data elaboration systems that can be required for Earth observation maybe, or moon missions. So if you are trying to put around the moon in an orbit, like 10 satellites to observe the surface of the moon or acquire new data and then analyze them and transmit them back on Earth, well, probably you would need high capability in terms of hardware and computing elaboration. So I'm thinking about also some tests that I'm going to be performed with the Artemis 2 mission. So I've talked about this in a previous video, so if you want to know the full thing, just go and look at that video here above. So they're trying to communicate from the Orion capsule back home on Earth through electromagnetic and lasers in order to widespread and widen the whole band of communication in order to be able to transmit higher amounts of data from the moon back on Earth. But there's a point, there's a problem. Well, first point and problem and solutions that data center are trying to give through their application is the fact that while it may be large and well, powerful data band of communication from like the moon to Earth, it can be larger and larger in the future, but will be limited in any case. So you still need to compress or pre-elaborate your data that you're going to acquire, which are destined to grow up in volume exponentially. So you're going to have more and more data from observations that are going to be transmitted to the surface of our planet to ground stations to be acquired and analyzed. Here the point is, if you can analyze them, pre-process them, and maybe compress or discard those useless data through applications in situ, basically you can reduce drastically the amount of band that you need to transmit those data towards the ground station. So how do you perform it? Well, first of all, you have to acquire those data. So you need the hardware, the equipment, the spacecraft able to acquire the data. And so the first computational power needed in this case. Then you have to elaborate those data in situ. You don't have to transmit them across like different domains, which may be the moon and Earth. If you're capable of elaborating this data in situ, you win basically. But you need strong and powerful hardware, like the one developed for data centers. That's the first point. Then you process this data and then you compress all those data in order to reduce their volume, and then you are capable of transmitting the data like towards the ground stations. That's the point. And then if you add to the equation like artificial intelligence, or just to be more precise, let's talk about generically algorithm. If you have powerful algorithms which are capable of choosing and discerning the useful data, those that contain information that is useful for scientists or companies, instead of useless information, so you can discern, you can discard like the majority of the information which is probably useless and only transmit the one which is useful and precious for the companies, for the scientists, for the agencies to be analyzed. Well, if you have an algorithm capable of doing this, you win again, because you reduce drastically. Like from 100% you can only transmit, I would say, 20% of that data, so you can reduce the occupation of the whole band of transmission, and you can reduce the latency time, the time needed to transmit one pack of data from the moon to Earth, for example. So you need a powerful algorithm, but a powerful algorithm also needs powerful pieces of hardware. So that's another point of why you would choose to develop data centers which are capable of staying and flying in orbit, well, around Earth or around the moon. Another point is the fact that those machines are so energy hungry, I would say, in order to be powered and in order to be cooled, that the energy we are producing just to feed them here on Earth is huge. Well, most of the companies, especially the new ones, on the contrary of what most of the people think and the public opinion wants us to think, well, those companies, I'm thinking about Amazon, Google, and also the smallest ones, are using clean energy, like the energy of wind, solar energy, or nuclear energy, which, well, you may think it's a problem, but it's actually a very, very good solution in order to power those data centers. But if you think that in space you have free sun energy, you are free to radiate towards deep space your heat. Well, on one side you have the capability of generating energy, so electric energy, and on another side you are capable of radiating your heat towards the cold deep space. And if you have multiple satellites like a constellation, like flying over Earth or around the moon, well, you can alternate those satellites which are producing or running algorithm in order to optimize the whole constellation in order to gain energy when they exposed to the sun and radiate the accumulated heat towards deep space when they are on the farther shadowed side of the moon, for example. So you see that the money point of view, the energy point of view, the cooling point of view, the communication point of view, so are all going to be aligned towards the same goal. That's the power of space data center. I'm not saying that's the solution for everything, but for sure for future space applications, that's a valid solution. We don't have any technology nowadays that has already demonstrated its flight heritage, its flight capability. So that's still something quite far from everyday experience, but that's a promising solution. So let me know what you think down in the comments. Subscribe if you haven't. So see you next video. Thanks.